So this lesson is going to be on the standard normal distribution. So the standard normal distribution, it's a normal probability distribution with a mean of 0, standard deviation of 1. So using our notation, this is going to be n parentheses 0, comma 1. So mathematically, we would take our normal probability function and substitute a 0 in for mu and a 1 in for sigma. And so this is going to yield the following: e to the negative 1/2 x squared all divided by the square root of 2 pi. Again, this is not something that you really need to know for the AP. This is mathematically speaking what this function is. We're going to be using tables and technology to find areas on the curve and to find z-scores for given areas. So example 1. Suppose we have a distribution with a mean of 0, standard deviation of 1, and we notate that n comma 0, 1. And we're often interested in knowing what proportion or percentage data falls within certain boundaries. So for instance, what proportion of observations is less than z equals 2? So our first step with this is to always draw and label a curve. Even seasoned statisticians do this to help them think through these problems, and you should do likewise. So I'm going to go ahead and draw a curve here for you. It does not have to be a work of art. Draw a quick little normal curve. We have 0, z equals 0, and so z equals 2. We'll put there's 1, there's 2. Just a quick shading here is all you need to do. Just helps us sort of think through this problem and even knowing what to put into the technology or how to use the table. So our first option, I'm going to show you how to use the table. So most students and statisticians sort of have turned to using technology, which will be options 2 and 3. Most statistics texts, including our online text, will include a normal probability tables typically in the back. And there may be some pedagogical advantage to using the table. So I'm going to show you how to use the table here just on this first one, and then maybe one more down the line when we're going the other direction. So this particular table that is associated with this online text looks like this. And what we do is we look at the legend. So this particular table gives us the area from 0 up to some value for z. Different texts will have different tables. You'll have to make sure you look at the legend that they give you. They will always give you some legend to show you what's being displayed in the table. So we need to find z equals 2 from the table. So I'm going to look here at 2, and I'm looking at that row, and this is actually 2.00 is what we need, so we're going to go over here to the 0, 0. If it were like 2.02, I would come over here and look at 2.02, but it's not 2.00, and so this is the column I look at, and so it's going to be this value here, 0.47725. Now notice I need to add this to what? I need to add this to 0.5, because what it doesn't show me is that's just from 0 to that value of 2 in this case. So I need all this right here. I want everything. I don't want just the area from 0 to 2. I want it all. So all of this here is 0.5, and this part here was the 0.47725. And we do that, we're going to get 0.97725. So that area is the sum of these two values, or 0.97725. Okay, so option 2, I went ahead and redrew the graph, and I've changed over to the white inking, so I think it shows up a little bit better. So option 2, we're going to use the TI 83 or 84. Here we're going to access the normCDF command. And we do this by pressing second and vars to access the distribution menu, and then select normCDF. This is the normal CDF function that we're going to be using. If you have a newer model calculator, it'll already pull up this syntax here, which is nice. We're going to put in the lower bound. To put in the lower bound, this is going from negative infinity. And what I use for negative infinity is this negative 1 E99. That's negative 1 times 10 to the 99th power. And the upper is going to be 2. So again, this is lower bound, upper bound, and then the mean, standard deviation, 0 and 1. You're going to press enter, select paste, and then press enter again, you'll get 0.9772. That should look familiar to us. Same value we got when we used the table. Occasionally you'll be off a little bit due to some rounding errors. If you have the older model calculator, you just put normCDF in, and then you have to know your syntax. Starts off with the lower bound, comma, upper bound, comma, mean, comma, standard deviation. Okay, same example. Third option is to use StatCrunch or some other sort of applet. I'm going to show you how to do this on StatCrunch. So note that this time AP exam does not allow the use of computers. So you're actually not going to be able to use this on the AP exam itself, but it does really help your learning, I believe. So I'm going to show you a few of these throughout the course if you haven't already seen them, and notice that we've been using these applets to help you sort of play around with some of these and to get a good conceptual understanding. So we're going to first press Stat, and then under Calculators, you're going to select Normal. We're looking at a normal distribution. So when you select this, you're going to put in a 0 for the mean, and we have 1 for standard deviation, and then we're going to put, we want this to be less than or equal to 2. And we get exactly the same value there, 0.9772.